Okay, if you guys are here, I'm just doing a sound check. All right, we sound good. So I guess I can kill the earbuds here. Get this put off to the side. Hey guys, man, it's been a little while. A lot has gone on since last time I saw you guys. I spent almost 14 days in my house because I hurt my back. Today I wanted to take some time, and I'm going to grab a chair just so I don't have to stand here the whole time. I'm getting more and more people that are messaging me, asking me specifically about the X7. It's not just Instagram, it's not just here on YouTube. By the way, I don't mind this. I don't mind that people are asking. I wish there were more resources that were available to people that were interested in manufacturing, because it's really hard to take a leap of faith or to jump into manufacturing when there really isn't much of a support net out there, or a safety net. Michael, how you doing? Glad you're here. I see there's a few of you guys starting to show up. This could end up being a long live video, and I'll tell you why. I want to take you guys through the X7. I want to talk about the control. We're going to grab the camera. I'm going to take you around. I'm going to show you guys the casting, the servos. It's pretty ridiculous. Before we get going, let me see what the time marker is. We're right around 45, 46 seconds in. I want you guys to understand a couple of things. I'm going to do my very best to tell you guys what I believe is like the unbiased truth. But please understand, I do have a business relationship with these people. They did step up to support a variety of educational and entertaining videos that I make for you guys. And so before you buy any machine, do not ever take one man's opinion for it. I don't care how much you trust them. If you can go see a machine, go see one. If you can go see it take a cut, go watch it take a cut. I would say just be careful. There's a lot of people out there that want to push things on you. That is not what this is about. Today, what I'm hoping to do is answer as many questions as I can in this live video, because I've had so many people ask me about this machine. And so I'm going to do my very best to tell you the good, the bad, the ugly, whatever it is. I want you guys to just be fully aware. When I never really talked about this, but when SYIL Machine Tool down in Houston, when they reached out and we started talking about this, they did something that like blew my mind and impressed me from day one. When we were discussing me making videos, I said, well, are you guys like going to try and like influence this? They said, Jason, we will put it in writing. We don't care what you do or what you say, what you make. We just want you to do what you've always done and do it with our machine. To have that level of confidence in a product is almost unheard of. I mean, I would say it is unheard of, and so I thought that was pretty awesome. Lo and behold, this machine has not disappointed, and we're going to talk all about that here shortly. So, looks like we got some people starting to show up, and man, there's people from all over coming in here. Alan Gibson here from the island of Madeira, it says. Nadav Mavor, Michael. So let's talk briefly about the X7 and exactly what this is. This is kind of interesting. SYIL themselves call this a hobby mill. I'm telling you, this is not a hobby mill. It's like a scaled down industrial vertical machining center. That's my opinion, pure and simple, okay? I'll do my very best here on this live video to differentiate between my opinion and fact. This machine right here is in the low $30,000 range, depending on how you, here in North America, it's in the low $30,000 range, depending on how you outfit it, whether you want a 4th axis or a probing system or a tool setter. If you want an umbrella tool changer or a sidearm tool changer, these things are all negotiable, I guess you'd say. All in all, I've been completely impressed with the machine's capability, reliability, accuracy, rigidity. It just doesn't compare. I personally don't think it compares to anything that I've ran that's similar in size. I guess before we get into like how to run the control and I bring the camera in a little closer, let me just tell you what let me give you a global picture. That way, if you don't have time to hang out all day, you can get it from here. I don't think you're going to get more physical products for your money. You're not going to get better spindle, rapids, table, travels, whatever. You're not going to get better for your money in a brand new machine than this. I just don't think it's going to happen. If the travels that this machine has fit your bill, I don't think you're going to do much better. Can you get more machine for less money by buying a used Fadal or a used VF2 or something like that? Sure, absolutely. It can happen every day. But there are some things to consider. Any of the industrial, my whole gripe, I shouldn't even say gripe, my whole concern with industrial vertical machining centers is that they tend to be unforgiving to newer machinists. So if you crash a machine at full rapid, I mean, this thing is so fast. I literally, I probably shouldn't show you guys this, but so we're going to take this down. I'm just going to show you how fast this thing rapids because you can actually jog this thing at full rapid, all right? So you can go to, I want you to watch this for just a second. Ready? It's pretty crazy, isn't it? If you crash one of these machines or an industrial machine at full rapid in the X and Y, more commonly in the Z, it's going to cost you a spindle cartridge. You're going to mangle the bearings. That's just the way it is. They're not designed to take that type of an impact style of load. I want to say, I believe that the spindle cartridge on this machine is around $2,500-ish, something like that. On an industrial machine, you could easily be looking at $6,500, $7,500, $8,500 for something that's entry or lower end of machine. And on something like a DMG or a Mazak or an Akuma or something like that, you could be looking at $15,000 to $20,000 just for the spindle cartridge. So it's no joke. The weakness to this platform at the moment, and I say at the moment because I know that the guys are working on it because I've been actively involved in it, is when you write the check for this machine, you get a tremendous amount of machine, you get a tremendous amount of capability. What you don't get is the most robust support system. There are other companies out there. We're going to compare this. I'm going to give you examples for two other brands, right? So if you buy a Tormach, you get the benefits of the Tormach are that it's single phase. You can buy it piece by piece and kind of build it up. And they have a huge support network, right? Their own proprietary controller, it's useful. There are a lot of guys that the Tormach is the right machine for. On the other side of that coin is, let's just say, the Haas TM0. Everybody knows that Haas just released a new updated, tool room mill, which is scaled down. By the time I was tinkering around, and by the time I outfit one of those TM0s, I think it was about $45,000 when they were kind of apples to apples. Now, the issue there is that, again, if you injure the machine or something like that, it's more expensive to fix. But if you're running a business, a Haas machine or an industrial machine has service technicians that can come save you. So I think the sweet spot for this machine are guys that are passionate about CNC machining. Maybe you've had a hobby mill or a CNC router and you're stepping up, but you're really not in a position to afford a full-on industrial machine. This thing is a great option, okay? So its weakness is that its support system isn't super robust yet. For now, the support system is pretty much the Facebook group, and there's a lead engineer in Asia that you can contact via Skype, and he gets back to you very quickly. Every time I've ever had a question, which isn't that many times, he's responded quickly, and so I don't have any complaints. And the other, so that's the first weakness, and then the second weakness is that this machine runs on 380 volts. It comes with its own transformer, but it needs 3-phase power going in if you want to run this Syntek Control. And we're going to talk all about this Syntek Control here on this stream. This is basically like a, in the words of people that I've spoken to about this control, it's kind of a FANUC-based, I don't know, I hate to use the word clone, but that's probably accurate, a FANUC cloned machine. It uses basically all standard FANUC G-code except for G20 and 21, which designate imperial and metric, are ran as G70 and 71 on this. I'm just making sure. Yeah. Well, Alexander says, what accuracy are you able to get milling aluminum without any compensation or spring passes? Well, Alexander, bear with me. We'll answer this in a little bit because I think that's a super loaded question. Is your end mill off size? Is there any run out in the system? I mean, that's not. If you're asking how accurate and how rigid is the machine shows up on location within a few tenths consistently, 3 or 4, never less than 3 or 4 tenths ever. More often than not within a couple of tenths. But there are so many factors. I don't know that's a super fair question. Let me segue real quick. Expectation is absolutely everything. Many of you guys that are watching this stream or have been around this channel, you guys have been hanging out with me. You guys have been watching the ups and downs that I've been through for years now. You watch me send a machine back. You watch me get my first Haas mini mill. You watch me get a VF2. You've watched this like progression. If there's one thing, like one revelation that has, that I guess I have attained, right? It's this. There is no perfect machine. There's no perfect machine. There's no perfect company. There's only machines or that are matched to jobs, and that's a big deal. I would beg you guys to temper your expectations with any of these machines. If you think that because you went out and bought a machine for, let's just say, $130,000 or $40,000, that it's going to be dead nuts accurate to 1/10,000th, think again. If you think that you went out and bought a $300,000 5-axis mill and it's going to be dead nuts accurate to 1/10,000th, think again. That just isn't necessarily true. And in many cases, it is not true at all. I know from experience. Okay, if you guys see, there's a question in the comments right now. Alexander, I'm not trying to be hard on you. I don't want you to feel that way. The question you just asked, I get that exact type of question so often. And I think that question in itself, it kind of reveals to me the thinking that's going on behind the question. That's all I was getting at. So the next question you see, is this better than a Haas mini mill? Better how? Better faster? Better more rigid? Better accurate? Better value? Does it fit in your garage and the Haas mini mill won't? I mean, what's better? I think this is why buying machine tools is so brutally difficult, because the criteria for how each one of us as machinists and business owners, as we judge the machines, it's not super clear what makes something truly better. So let me bring you guys over here real quick, and let me give you the gist of this machine. It's got about 50, I believe it has about 15.5 inches on the X. I think just about, was it 11 inches? About 11 inches on the Y. And I want to say 14 inches on the Z. I could be wrong. I'm going to put a link to the PDF spec sheet underneath this video when we're all said and done, so you guys can check the travels. I'm going to bring the camera over here so you guys can see a little bit more inside the machine, and then we're going to talk about the control. So this machine came with a manifold right here that had 3 nozzles pointing down, but we had the fog buster on here, and I put the fog buster on here so that we could film better. We just wanted to be able to film, and obviously you can't do that with a ton of flood coolant. So I put this lock line on here for the time being, and this is air blast. This is a spindle that can go up to 12,000 RPMs. They recommend that you don't run it max continuous above about 8,000 or 8,500. I have found that running it at about 8,000 or 8,500, it'll get warm, but it doesn't get super hot, so I haven't had any issues. If you guys are newer to machining and you haven't ran any programs that run for hours and hours, like you're not surfacing or you're not using a super small end mill, what happens is when this spindle cartridge begins to heat up over time, this head begins to suck up heat, and then what happens is the head will actually grow, not by a lot, but maybe 1,000th or 2. And most of the time, that if your tolerances are 4 or 5 thousandths, that doesn't matter. But if you really do want to work to the edge of the machine's capability, you need to account for the heat that's being generated in the system. You can see that it's got this Pioneer touch setter. It's way off. It's way off The travels in this machine are something like this right here. I don't know if you guys can see that. The travels, so you got this Pioneer touch setter. The travels of the machine are about like this. And I've got it pushed way back because I had a magnetic chuck on here because we were cutting a mold base that was 14.4 inches in X. So we were working right up against the limits of the machine. If you see, it's got some gnarly way covers. Let's see here. These things are like, these, I mean, these are some just insanely heavy duty way covers, man. It's pretty gnarly. I had a chance to talk to the guys over at SYIL in Asia, and they brought up something that was really interesting. They've basically what SYIL has done is they've built this machine from some of the best name brand components you can get your hands on. I mean, this thing has a, you know what, I guess I can't do this. Hold on one second. I'm going to take this whole thing, I'm going to take this whole camera with me, this whole rig with me, you guys, so bear with me. I'm going to try this. I'm going to pull it off the tripod and see if this works. Hopefully I don't drop anything. No promises. Oh, there we go. Okay. All right. So if you look right here, you can see the coolant. Let me zoom this thing out. Okay. So here's the chip bin, and you can see we've been making tons of chips. Here's the coolant tank, coolant pump, which makes quite a bit of pressure. That's the 4th axis, which we're not using. This is the transformer that the machine comes with. Here are all the solenoids. This is the one that you can adjust for air blast if you want to increase or decrease the air blast pressure. Right here you can see that this is a Schneeberger. If you guys are bored, go Google that. A Schneeberger, I mean, you can see everything about this. You probably even see the serial number. A Schneeberger epoxy granite casting. Now I want to take you guys to the other side of the machine. By the way, you can pull tools out right here if you need to. So you don't have to pull them out from the spindle side. You can actually pull them out by hand right here if you remove this window. I leave a magnet here with this so I can get this window out anytime I want. So here's the column. I mean, look at it's hard to compare this to a hobby mill when the column is pretty ridiculous. Look at this servo. Look at the size of that servo. It's pretty gnarly. Here's the electrical cabinet. I can't get back there though, it's too tight. I hate the fact that this camera, once I turn the light on in the mill, watch this. I'm gonna turn the light off inside the cabinet and watch how everything, see like right here, it's all yellow? I hate that. When we turn the light off, watch, it'll probably go back to white. Yeah, see? Isn't that ridiculous? All right, so a lot of people ask me about the Syntek Control. So I say we take a few seconds and we take a quick look at the Syntek Control. Everything turns yellow because the control's white. Man, I got to get a better camera, you guys. All right. So let's just say we were going to import a program. People ask all the time about how difficult this control is to use. To be completely fair, I do have a prototype version of, I have a special screen set in here that I've been working on Syntek America with. And so I'll show that all to you right now. Any of you guys that already have one of these machines, if you don't have this screen set, just understand that it is going to be available. It just isn't there yet. They're still working some details out. So as you take your USB key, you install it. I just toggled the screens up here. So you have information, which is your main screen. You have NC, which I never use. You have your work and tool offsets. So here's all your work offsets. You can page down. You guys can't see, but I'm just using these buttons right here. They obviously aren't in the camera, but you can page down. You can hit enter. You can run this just like a normal keyboard. This is something that's pretty interesting. You go to Workpiece Coordinate, and you see how you have these relative coordinates? These are really, really useful for using the machine as its own measuring tool. And so you can jog the machine down until the spindle nose, you jog the spindle nose down, then you bring it up until the block goes underneath it, and then you zero these by hitting 0 all relative coordinates. Now, when you jog the machine back up in Z, you put a tool in it, and now when you do the exact same thing, you can check how long your tools are with a 1, 2, 3 block or a gauge block if you don't have a tool setter. If you want to change your machine coordinates, you just put your Heimer or an edge finder into any of these. We'll just say we'll go into G54P3, which is G56, and you just hit apply machine coordinate. Yes. Apply machine coordinate. Yes. Now the Z is a little bit different. You can hit apply machine coordinate, and now if you have your Heimer in the spindle, you can hit gauge increment, and my Heimer is tool 95. So this is actually still, there should be a white thing behind this box. I told you the software is in development. But you just put the number of your Heimer in here. You put whichever offset you're working in. So 1, 2, we were in 3, right? So 3. And now you hit apply gauge increment, and it's going to take 6.24 inches. Boom, and now we're set. And that's all you got to do. So if you don't have probing and you're doing everything manual, I just showed you the core idea of how to do this. If you guys want to see it in person, I missed that. Someone said something. Let me see if I can pull this up. I saw somebody say something about getting orange. Yeah, if I had a camera where we could lock the white balance, unfortunately, the only way for me to run the Canon 80D is through OBS Studio, and it just, you guys, to be honest with you, when we're doing these one-man videos, it's just too much. It's just too much for me to keep up with. All right, so I'm gonna see if we can do this. All right, you guys, so here's what we're gonna do. I'm gonna show you exactly how to touch off a tool. And here's what I want you guys to do. I'm gonna work in the back corner of the machine over there. Well, actually, I guess I don't get a choice. I'm gonna work right here under the spindle, and then I'm gonna want you guys to keep track right here. So here's how I would do this. You know, this might not reach, I might have to get a 246 block. Yeah, I think I'm gonna have to get a 246. Let me grab a 246 block. I normally do this with, come on, is this gonna reach? Oh, it does, okay. So here's how I would do this. I know you guys can't see this, so this is not trapped. You never wanna jog down onto something like this, okay? So we're gonna spin this up using the 1,000ths until it slips under there, and it's just about ready to go. Okay, so it goes. Now we're gonna take the 1,000ths, we're gonna go down 2,000ths. 1, 2. We had to go a couple more to get it down. Now I'm going to use the tenths and I'm going to bring it up. Okay, so I'm pretty comfortable with that. So this is where the machine thinks it is. We're going to 0 that. So 0 all relative coordinates. So now we have a reference surface. We can put a tool in, like this master calibration tool. I'm not going to use this master calibration tool because I don't want to confuse everybody. Because here's a little bit of trivia for you guys. Can anybody in the comments tell me the difference between the spindle nose and the gauge line? So we're going to put this tool in here. We're going to come up. I came up a little bit too high. Okay, now we're here. So this tool is 3.1685 inches long from the spindle nose itself. And that's it. So now all you would do, I'll slide this out of here, 3.1685. So this is tool 9, at least that's what it thinks it is. So we would go basically just like this. We'd go back, tool set, we'd page down to tool 9, geometry length, 3.1685, 3.1685, enter, boom, tool length is set, moving on. It's literally that simple. That's all you have to do if you don't have a tool setter. If you have a tool setter, then obviously you can just touch everything right off the tool setter. I really feel like some of these tools are really, really valuable. I feel like having a tool setter is really useful, and if you're running small tools and you need tool breakage detection, it's a great investment. It's an absolutely, totally 100% worthwhile investment. If you're not running lots of different jobs, if you're not setting stuff up, if you're a guy that invented a product and you're in your garage and you just make that same product over and over and over, then maybe you don't need that, you know. It's totally up to you. So, okay, so let me tell you guys why I brought up the whole, let me tell you guys why I just brought up the whole thing. I was going to avoid this because I don't want to confuse you guys, but a gauge line inside of a spindle taper is a theoretical place where the taper reaches a specific diameter. This is almost never the actual physical spindle nose, okay? And I'll show you what I mean here. I'm gonna point this right back down here. So I actually have this tool that I bought from Mara Tool, and it tells us that this is exactly 2.9999, so 1/10,000th of an inch short of 3 inches. It tells us that's how long this tool is. Now, what I'm going to do is I'm going to take our 246 block and I'm going to jog it down here. Are we on? Yeah. And I'm going to show you guys the issue here. Okay, so, okay, I would say that's tight. So we have 3.0039, okay? Now, I can promise you guys, the X7 is not off by 4 thousandths. That's not the case. What's going on is that the way this spindle taper was ground, it just happens to work out that the way the spindle taper was ground, it just happens to work out that it's like 4 thousandths from, you know, a smidge over 4 thousandths from the gauge line that the spindle nose is. So if you calibrate this tool setter using this at 2.9999, you cannot touch off tools manually accurately. Now that we've done this, if we calibrate this tool setter and we tell it that this tool is 3.0039, a couple of thousandths. By the way, just to give you an idea, I had someone else do this the other day, and they had it at 3.0042, so 3/10,000ths. That's pretty damn good, pretty damn close. Actually, you guys probably, I don't know if you guys can see that or not. I had someone else do it, and they got it at 3.0042. If you tell the tool setter that this thing is 3.0039 or 3.0040 or whatever, and you cheat it a little bit, now you can touch tools off using the tool setter. And let's just say, look what I did. I've got the tool setter so far over that you actually can't get to it. So I'll show you guys what I mean. Look, that's as far as it goes, so I can't reach it because I was running a job that was bigger, you know, too big. It was using so much of the travel that the tool setter couldn't fit into the working range of the machine. But because I didn't tell you guys this, but because I calibrated everything using 3.0040, I can use the tool setter and I can use the spindle nose interchangeably during jobs. So this is, honestly, it's probably a little bit more involved than I had intended to get, but it is true. It can be done. So really, I guess what I'd like to ask you guys is what questions, I get so many questions on this machine. What is it that really, let me bottom line it. Let me bottom line it for you guys. So many people, I think it's important to manage your expectations. Value for the, you know, $30,000-ish dollars, it's 32,000, whatever it is, 32, 33,000 bucks. I believe this machine is 32 or 33,000. That's, I got a special deal, obviously, because I'm working with SYIL, but for 32 or 33,000, you get the machine with a Syntek Control with a tool setter, which I think is a pretty damn good value. The strengths are that the machine is rigid, accurate, epoxy granite casting. I mean, you can see that it's, they use, I want to say they use like THK ball screws. Obviously, this, I shouldn't say obviously because it's not obvious. When you buy a machine like this Syntek controlled machine has all Syntek servos. If you buy a Siemens machine, it has all Siemens servos. If you want a single phase machine, they do offer one with an LNC controller, but I'm just telling you guys, I don't know anything about it at all. I don't know anything about LNC. I've never seen one. I've never touched one. I don't know anything about it. Let's talk about like if something goes wrong. If the machine stops working, or if it's damaged, or if you injure it, now what? This is really what you have to be prepared to deal with. Now on a Tormach, you built the machine yourself, or you assembled a big part of it yourself, and you're pretty much expected to work on it yourself. On an industrial machine, like let's just say a DMG Mori, if the machine gets injured or damaged, they send a technician out for you, to fix it for you. This is where you have to, this is probably what would be the deciding factor. I don't think the value here is in question. What's in question is, are you prepared to repair the machine yourself if you have to? That's just the biggest issue. Are you prepared to do some alignment? Are you prepared to, you know, realign the tool changer, or, you know, whatever it takes if something goes wrong? And so that's probably the biggest issue. Let me see what we got here for questions. This is a, this thing uses super high end. It uses THK linear rails, THK ball screws. I mean, this uses, like I said in the beginning, and you can go look on the SYIL website. It's pretty stunning. It's pretty stunning what the kind of package they've put together. Someone says the industrial controllers are still not up to the ability of running adaptive toolpaths without getting massive memory upgrades. Actually, that's not true. This thing is more than capable of running adaptive toolpaths. This thing actually has something, if you guys have a second, they use it as G120. It's called HPCC, High Precision Contour Control. It's a FANUC option, so you guys can go do some research on that. If you guys are curious, you can go play around. You can go over to, like, I'm assuming that most of you guys are using Fusion 360. You can go to the Fusion 360 post processor download page. You can download the post for the Syntek Control, and you can see that there's an option for basically high speed, high accuracy, that kind of thing. Let's see what else we got down here. Yes, this is an epoxy granite base, yep. Okay, so Casey Dvorak is asking how it might compare to the Haas Toolroom TM0P. So Casey, okay, so I guess let's talk real quick about I said that this was X7 everything, and so let's do the deep dive. Let's talk about the Haas TM0P. Well, let me do this. Let me talk about my mini mills, and let me talk about my mini mill, which I loved, by the way. It was great to me, and I made a ton of parts, and I don't think it ever had one single service call. And let's talk about the tool room mills. So I had a Super Mini Mill 2, which is basically the mini mill 2 with faster rapids. I think it was like 1,200 inches a minute or something like that. It had a 20-tool umbrella ATC. You can no longer get a side mount tool changer on the mini mill series for whatever reason. I mean, they probably just didn't make sense for Haas or whatever. I loved a lot of things about the mini mill. There were a couple of things I wasn't aware of when I bought it. Number one, it doesn't have any windows on the sides. So if you do end up needing something like a linear rail changed out, that means the sheet metal may have to come all the way off to get a linear rail out. If you have something that needs to be serviced back behind the table, that means the technician has to crawl into the machine to get at it. They're not just reaching in through a side window. That's something to consider. So service could be a little bit more expensive. By far, I thought the biggest weakness of my mini mill was the fact that it sat on a sheet metal base, right? If you go look like in the Haas operators group or some of the other forums that are out there, what I should have done is I should have airdropped the picture to my iPad, and then I could have just showed you guys. But the mini mills basically have like it's like, when I say sheet metal, I think it's like 1/4-inch plate. It's not like it's some flimsy base, but it's still, nevertheless, it's not a casting that sits on the ground like the tool room mills, and it's not a casting that sits on the ground like this X7. I loved my mini mill. I didn't like the coolant situation. It drains coolant into the stand, and it doesn't have a separately removable coolant tank. And so I'll see if I can roll this out a little bit. I got to be careful because I hurt my back a couple weeks ago, you guys. I definitely am not looking forward to getting hurt. Move some of this crap out of the way, and I'll show you what I'm talking about. This whole coolant tank, that's about as far out as I'm going to get it right now. But this has a tray and a coolant tank that runs back like in an L shape. It's an L shape back here, and it comes down here. And so when you want to clean the coolant out or you want to change the coolant, it's so much more useful to have a coolant tank that way than to actually have it in the stand itself. And so that's probably one of the things that I didn't like. I will tell you, though, that the amount of programming support and stuff like that for mini mills is great. The TM0, let's talk about the TM0. I went and looked at it, and I think what Haas is doing is pretty awesome. I think that they're lowering the barrier to entry for manufacturing. Here's the argument. How much value do you get? And for that TM0, I believe the one without a tool changer was right around 28 or 29,000, which, by the way, is dirt cheap for an industrial machine. But as you start to outfit the machine, if I remember correctly, and bear with me, you guys can head over to HaasCNC.com and check it out for yourself right now. I want to say to get to something that was about around this range, I was at 45 or 48,000. And so let me just tell you some of the options that I think you have to do. You have to take the machine, which is, let's just say, I think it goes to 34,000 with a tool changer, if I remember right. So you go to 34,000. You've got to add high-speed machining, which is a few $1,000 because this machine has that. It has all this look ahead. It has high-speed machining built in. You have to add a 10,000 RPM spindle because this particular machine has a 12,000 RPM spindle, which I don't even think is available on the tool room mills. I guess one of the strengths, I would say the two strengths for the TM0s are that, number one, if something happens, there's a technician that'll show up and they'll save your butt. Simple as that. So there's no arguing that. That is a clear win in their category. The other win is that I think those machines are actually available to some degree or another in single phase. So there are some benefits to that, but by the time I had done all my outfitting, this $33,000 machine was like 46 or 48 over there. So I guess take that for what it's worth. You know what I mean? I wouldn't buy a machine without a tool changer. There's no question. Can you get away without probes? Sure. Can you get away without a tool setter? I do it every day. But would I try to get away without a tool changer? I don't think I could do that. You got to have a tool changer for sure. So let me see if there's any other questions. Did I answer that question to you guys satisfactorily for you guys? Casey, I can tell you that on this machine, I've taken, I want to say it was right around, if you guys watched any of the earlier videos, I want to say I was running, I got some tools laying out around here. Let me see if I can find them. I've got this shrinky from Maratool. And is there another one in there? No, I took it out. I've got this shrinky from Maratool, and I had another one. sorry. So I've got this shrinky from our tool that had a YG, and then I had the shorter one. And with the shorter one, I was doing, I think, right around 900 thousandths depth of cut. So what would that work out to? Like maybe 21 millimeters depth of cut, something like that, with, I want to say, a 30 thousandths step over, so 0.8 millimeters. And I want to say I was 2 or 3 thousandths per tooth. So I was pretty stunned by the level of rigidity that the machine offers. It's rigid enough that the cut sounds good while the spindle starts to bog. So take that for what it's worth. It will bog the spindle, no problem. On this machine, you can get, this has an umbrella tool changer. So I guess I never really talked about this, but why this machine, why this configuration in this shop? When I talked to the guys at SYIL and they decided to help out with like basically me creating videos, they said, well, what do you think about a machine? Like what's super important? And I told them, I said, listen, they had this control, the Syntek, they had a Siemens control, they had an LNC control. At the time, they had like a gang of controls, Fanuc controls. And I said, look, whatever you think is like the most commonly used configuration and provides kind of like the most value for the end user, why don't we do that? Maybe that's the right answer, because you don't want to show people the Ferrari that they're never going to buy, right? Don't get me wrong, I personally would love to have a side mount tool changer. This holds 12 tools. It works great. I actually didn't show you guys the tool change routine on this thing, so let me show you that real quick. This is actually pretty awesome. So when this machine, to finish that thought, we chose this machine very specifically because it was the most commonly, we believed it would be one of the most common configurations of machines. Now, check this out. So when you go to information, you go to file manager. When I used to want to do probing, I would have to go into inch probe and I'd hit enter and I'd have to choose one of these routines. It was kind of a pain in the butt. When I wanted to do tool setting, I'm using the wrong button here. You got to choose, I keep hitting back, but you got to hit these two dots to get back. So there, it takes us back. When I used to use the tool setter, I would go to inch TTC, touch tool setter. I would hit enter, and then I would choose a diameter calibration. I'll show you. What I used to do is I'd go to length measure, I'd hit enter, and then I would have to go in here and I would have to change this tool number for whichever tool was in the spindle. It was a little bit cumbersome. And so the guys from Syntek America came up here and we sat down for a full day and we discussed workflow. And now you don't do this anymore. Now what you do is you come to your work coordinates tab right here. Let me turn this over so you guys can see a little bit better. You come to your work coordinates tab and you just type in, look, tool change. What tool do you want? Down here, it tells us what we have. We pocket 9, tool 9. And so we're just going to say, you know what? We want tool 1, enter. The door lock button was on. Execute tool change. So we'll do that one more time. In all fairness, you guys, I have the door lock overridden so that you guys can see the machine run the way I want you to see it. If you guys actually had one of these machines, this button right here, this locks and unlocks the door, F4, okay? All right, so let's do this one more time so you guys can see. All right, so we've got tool 1 in the spindle. Let's just say that we want to get, I don't know, tool 12. You would just hit tool change, 12, enter, execute tool change. And now it goes and it grabs tool 12. The guys over at SYIL told me that they wanted to speed this whole process up, but I told them, I'm like, man, we're not trying to be a Brother Speedio. I think it's super reliable. I've knock on wood, it's worked really reliably up until this point. So let's talk about some other things. If you wanted to run the tool setter right now, you just touch tool setter button. You can either run calibration, center, or non. So we'll just hit center cutting. And now it shows you the tool setter. All you have to do is put the offset number in here. Choose right here, length or length and radius. We hit length only. Approximate tool length, which you just use with a scale. You know, you just kind of stick it up there to see how long it is. And then you can decide if you want the spindle to rotate backwards or not. And you hit execute, and it grabs. And if you notice, the guys at Syntek America put a tool change button here so that you can just, when you're setting up a job, you can touch your tool, grab the next one, touch your tool, grab the next one. It's pretty slick. So let's get back to, and then non-center cutting will actually, it'll do a shift. So probe functions, it'll do bore boss, it'll do all this stuff. They built all these screens so that you guys don't have to use those text files I just showed you. So it's pretty awesome. If you're using a Heimer, you can go to Workpiece Coordinate and you can do manual center, and you just touch the left side of the part and you hit PX1, right side of the part, PX2, PY1, PY2, and then you can latch your coordinate. After you get that, you can latch it to whichever work offset you want. So if you were using G54, you would just hit latch it and it'll latch it right to G54. If you're using G55, 56, 57, 58, 59, on and on, you just put that number right here. So let's just say we go down, let's just say you wanted to use G54 P21, you could, but obviously 1, 2, 3, 4, and on and on. So am I going too fast, you guys? You guys with me on this? Someone says, how often do they update this? I would say almost never. There's really not a need. I just saw a comment that said, hey man, it feels like it's from 1994. I guess I don't disagree completely. I had a pretty interesting phone conversation with a software company yesterday, and there's a fine line between updating a piece of software, that whole not enough versus too much thing. When one of the guys that works for me that does some programming and cutting here in the shop on this and on the 1100, he came to me, he's like, dude, what is going on with the post screen in our software? And I think it's tough. You definitely want to add new features, but I think businesses need to be able to decide when they want to update all of their software. It's tough to be forcing things on them. I find the workflow on this, keep in mind, this was designed to be a competitor to the FANUC line of controls. Now, Syntek America told me that this is one of the second most popular control in Asia. I don't know if that's true, I can't verify that, but it wouldn't surprise me. I think we need to ask ourselves, what do we want in a control? Do we want the easiest control to use in the world? Or would you rather have a control that's very easy to use but totally unreliable? Or would you rather have a control that's super reliable but a little bit cumbersome to use? And as far as I can tell, this has been very reliable, and Syntek America has the ability to upgrade it and make it easier to use. So I'm pretty thankful for that. So I don't know much. I've seen the Siemens control. I don't have any day-to-day experience with them. For the most part, here's my experience. I've ran the Akuma control. I've ran PathPilot quite a bit. I've ran the Haas Next Generation control. And I've ran this, and I've played around with some FANUC controls in person. That's about the extent of my experience. I can tell you that all in all, I like this big screen. I don't know how I feel about it. I don't know if I would rather it be touchscreen or not. I like these tactile buttons. I do not like flat buttons. The buttons that are kind of like they're little, I don't know. They just call them, you know what they are. They're flat buttons. They're almost like you can't feel them, but they kind of depress. They have the little clicking sensation, little tactile sensation. Let's see what we got here. Let me scroll over here and see what we got here. All right. If you guys could do me a favor, I appreciate it. If you guys are enjoying this, like kind of this two-way interaction, do me a favor, click the thumbs up button. It basically tells the YouTube algorithm to share this video more, and that benefits me. And by the way, it doesn't benefit me necessarily monetarily because there's no ads on this video. It just benefits me by helping expose this type of content to more people that are interested in manufacturing. So if you're enjoying this video, please click the thumbs up button. I got my iPad here. I'm trying to follow the stream with you guys so I can see what's up. Yeah. Harindu Gamlath says, Haas tutorials are a great reason why someone would stretch their budget to buy one. If SYIL wants to be competitive, they really need to put more tutorials and videos on the web by themselves. I agree. And okay, so just so you know, they 100%, 100% agree. I bought my first CNC machine because the videos that I watched online gave me the confidence to do it. I knew how to run the control before the machine arrived. And so they know this. The reason you guys are seeing this video right now is because SYIL understands that they need more content out on the web. Now, there are guys out there like Aaron Powder who's put up quite a bit of content. There are other guys like Grant Takara, Peter Betts, Betts Technic that are putting out content. There's content. I'm actually getting ready to do kind of like a review video on this machine where it's going to be a little bit more formal, you know, better graphics, better sound, all that kind of stuff. And in that video, I'm going to share with you some of the projects that other guys that own these machines. There's a guy in the forum named, I'm probably going to butcher this, I think it's French, it's probably Piet, but I call him Piet. And he makes these little like RC, either airplane or helicopter engines, and they're absolutely awesome. But SYIL does know that they need to create more content, and that's why we're making videos like this right now. They are going to do dedicated factory-based content where it's going to be 2 to 3 minutes a piece, and it's going to show each operation. When they take cuts, they're going to give all the information for like the end mills, the work holding, everything, the feeds and speeds, so that you guys can go out there and, you know, it just builds a foundation of understanding and trust. Someone said, will SYIL run an F1 team? I hope not. I hope not. Oh, that was pretty funny. That was good. All right, let's see here. It depends. You can spend quite a bit of money on these things, but this one right here is, keep in mind, you guys, check the upload date. If you're watching this and it's not live, check the upload date. You guys see what the economy is doing. I was told, I checked the news yesterday and it said there's 59 ships waiting to get into port in Long Beach here in the United States. And so, man, it's kind of hectic. This machine here is right in the low 30s as you see it with a tool setter, okay? Something like that. If you want to get a sidearm tool changer, this is a 12 tool ATC. You can get a sidearm, a 16 tool sidearm. One of my buddies has this machine. He has the cast iron version of this machine with a 16 tool ATC. He actually really likes it. So the tool changing, okay, so no, this tool changing routine is not standard. I think it's going to, I'm not sure. You know, I wanted to share with you guys what's going on. It'll either be standard or a very inexpensive screen set at some point. I'm really not sure. I don't know. I guess I don't want to make promises I can't keep. I do know that it will be available if you want it. How's that sound? All right, hope that's a good enough answer for you guys. All right, let's see here. Can I fit a 3-inch shell mill? That's a great question. I'll show you the shell mill that I've been running. Well, I would say you probably can, because I run this ITS boring head, and this is my Mitsubishi ASX 445. So yes, the question is, Scott, is this machine, it takes a pretty rigid machine to run a 3-inch shell mill. And I can tell you that my super mini mill, when I used to run the 3-inch shell mill, a 3-inch 5-insert shell mill in the super mini mill in steel, its max depth of cut was like 30 to 40 thousandths with like a 70% step over. And what would happen is it would cut really cleanly, and then when the leading edge would come off, it would kind of flex back, and you'd kind of get some witness marks on the back side of the shell mill, which tells me that I was probably pushing it just a little bit harder than it probably preferred. I really feel like all these machines have a sweet spot for a tool size. If you've watched any of the John Saunders videos or almost any of these guys that do machine videos, what you'll find is that most machines kind of have a sweet spot. I felt like on the super mini mill, it just loved 3/8-inch tools. In fact, I've got a gang of 3/8-inch tools. Let me see here. I buy a variety of tools from a variety of places. This is a Kodiak cutter. I don't know if this will actually come into focus or not. This is a Kodiak cutter, and this is a tool that I run a ton. This is a 5 flute, 3/8 inch. I want to say that's like maybe a 625 length of cut. Yeah, 5/8 inch length of cut. This machine here loves this tool in steel. Yeah, I can run this all day. 400 surface feet, 2.5 thousandths per tooth, 500 thousandths deep, 10% step over. Usually that's where I do it because I do a lot of like adaptive and trochoidal tool paths. You can really lean on like an 8mm or a 5/16 inch cutter in this machine, no problem. But that's in steel. In aluminum, I run a lot of the 3/8 stuff. I just run the polished YG tools in 3/8, and it does a great job. Like it never even stutters. It's just recommended feeds and speeds, no problem. Let me see what else we got here. This control does have some conversational cycles, but I'm not going to pretend that I've ever used them. I've never even tried to use them. We post everything right from cam. Maybe I answered this, but how's the accuracy? This machine has actually been quite accurate. Somebody asked a little bit earlier about, how accurate does it cut, uncorrected and all this kind of stuff. That's just not real world. No, I don't know a shop. Let me rephrase this. Maybe something like surfacing goes uncorrected, okay? But it just doesn't. That just isn't super. It isn't super common to program a part and have it be. If your tolerances are plus or minus 1,000th or 2, this machine will do it in its sleep. You don't even have to worry about it. But what I find is that a lot of people have these insane expectations about tenths of 1,000th, or let's just say, I don't know, 15 microns or something like that. I don't think people realize what it takes and how many factors influence the cutting conditions alone. The work holding, the cutting conditions. I can tell you that here where I live in Bakersfield, California, I woke up the other day, it was 60 degrees out, and it was like 96 before the end of the day. That's a 36-degree swing throughout the day. This shop that I'm in is not air conditioned. We have like some venting fans and stuff like that, but basically we suck all the cold air in the morning, then we shut the door, and we just wait it out until about 2 o'clock in the afternoon when we all go home. That's the way it goes. So I think that chasing 10 thousandths is... A guy that works for a CNC machine tool company once asked me a question. He said, Jason, are you having a problem making good parts? Like whatever it is you're making, are you making good parts? And I wasn't, because I was kind of like agonizing over the accuracy of a machine. I think when you buy a machine like this, what you need to ask yourself is, what are you going to make and what do you expect? If you expect this to hold tolerances like a kern, you're just being unfair. That's just unrealistic. Now, if you want to hold something to say within 1,000th or better, I don't think you're going to have a problem doing that. Now, if you take your first cut, and let's just say a 1-inch boss, a 25mm boss, and let's just say that it's 1 inch and, I don't know, 2 thousandths. You can correct your offsets. You just go into your tool set. You correct your wear value. Let's just say tool 9, that's what I did. You just say, I don't know, maybe minus 0.001. And now, when you rerun that thing, it's going to be on size. It's just that simple. So, what do you have for run out? Are you using an end mill collet holder? Are you using an are you using an end mill, like a side lock holder? Are you using a collet chuck? Are you using a shrink? Are you using hydraulic? Are you holding onto your part with like the majority of the vice jaws, or are you just barely hanging on to it? Are you squeezing a plate and creating some bow? There's just so many factors. I have found the machine to be safely accurate, well within 1,000th, but I think it's so much safer to underpromise and overdeliver than for me to tell you guys that it's going to cut within 2/10. If you guys are seriously interested about buying one of these machines, go see one. There's another guy that just put up a video. It was in the SYIL group on Facebook, but I think when you guys get rid of this video, when you guys get off this live video today, go type in SYIL X7 accuracy. And a guy just did a video. He cut a part and he sent it off to a CMM. And I don't think that there's a better testimonial to its accuracy and a real world results, then probably something like that. So I would go check that out. Okay, all right. So we got 58 people watching. You guys, we've been on here for, let's see, does it tell me? It doesn't tell me how long we've been on here for. I feel like I've covered the majority of what's going on. The machine comes with air blast. It comes with a pretty powerful coolant system, which let me jog the machine out of the way real quick. What's going on here? I just don't want to cover the table in coolant because I got to, when I get done with this video, I'm going to be setting this thing up. It's just telling me I got a soft limit exceeded. All right. This thing makes plenty of coolant pressure. And I think my coolant. And that's like a 3/4 inch hole. It makes a tremendous amount of coolant pressure. And all in all, I think it's a capable, useful machine. If you guys noticed, I'm gonna do this real quick. If you guys noticed, this is where the machine dumps its coolant. It runs in from the back. By the way, I've been thinking about plumbing in some coolant lines back there for like a wash down, for like a shower. But I guess they're talking about putting in a chip conveyor setup for this at some point in the near future. They're working on designing a custom chip conveyor so that if you do run high production, you'll have a way to evacuate chips without having to reach in there with like a little scooper or something like that. So, all right, well, I think that's about it, you guys. Let me see if I missed anything. We talked a little bit about the control. I showed you guys how to touch off tools. We set work offsets if you're going to use the Heimer. I showed you that there was some old kind of text-based, macros and stuff like that for touching off tools and setting work offsets that have now been updated into this new screen set from Syntek. Hi, Nick. Hope all is well. Yeah. Okay, 38 minutes. Okay, cool. Well, if you guys want to, my goal here in this video was really to create a piece of content that answered as many questions as we possibly could, because I'm just surprised at how many people have reached out and asked about this. I've talked to a couple of machine tool companies here in the last month or two, and apparently right now, machine tools are selling like gangbusters. Like everybody is just like backed up for months. Like I talked to one company that was out for 20 weeks out, another company was out for 11 weeks out, and so I get the feeling, I don't know if there's more manufacturing that's coming back into the United States or what's happening, but clearly there's a lot of you guys out there that are looking to buy machines. If you guys have questions, if there's anything you can think of that you'd like to know about this machine that I haven't answered, I'd like to answer it right now because I'd like to create the most complete kind of archive of information. I said this in the beginning, but I'm going to say it again. SYIL stepped up in a big way to support me and help me create a variety of educational and entertaining content, and it's important for you guys to know that. I would not encourage anyone to buy a machine on my advice or anybody's advice. I think you should go see the machine, ask for a test cut, see the machine move, make sure that all the questions that you have about service, repairs, warranty, costs, accuracy, make sure it's all answered, right? If something goes wrong with a spindle cartridge or the tool change or something like that, on a machine like this, more than likely, you're going to be responsible for fixing it, and it's very important to understand that. Does that mean you shouldn't buy it? No. I think for 33 grand, I think this thing's a smoking deal and gives you a huge amount of capability. If you were doing, I don't know, lowers or slides or, whatever, running boards for Harley Davidsons, this thing could rip through, this thing would shred aluminum all day. We've cut tool steel all day. Let's see here. Someone said the used market for machines has gone mental. Yeah, I see. This guy said he had 7 offers on his G0704 in 1 week. That's insane. Okay, guys. Well, if there's no questions left, I appreciate you guys coming to hang out with me a little bit on this Saturday morning. at the end of the day, I've been super impressed with this machine. Is it perfect? No, there's no such thing as a perfect machine. There's no such thing as a perfect company. But this has allowed me to make a variety of fixtures. I have done some tight tolerance stuff that's very, very accurate, but I'm not going to tell you how accurate because I don't want to set an expectation that if you find it hard to achieve, you're upset with me for. But I can tell you I've done some super accurate work on this machine, and so I've been super impressed. We've cut a lot of steel in this machine. I love running the die jet, high feed mill, 15,000 depth of cut, 10 or 15 thousandths inch per tooth, 5,000 RPMs, 150 inches, 180 inches a minute. It chews through steel no problem. If you guys have questions or you want to find out more about this machine, you guys can reach out to SYIL Machine Tools down in Houston, Texas, if you're here in North America. If you're not in North America, because I realize there's a lot of you guys watching from all over the world, you can reach out to the SYIL Machine, I think it's just SYILMachineTools.com, and I think that all that information will be funneled to I don't know if it's the owner who's in Asia speaks English, and there's a variety of different guys throughout the country. There's a guy in Europe that speaks perfect English and stuff like that. So if you're watching this video, you probably speak English, right? Hope you guys enjoyed watching this video as much as I enjoyed making it. Get out there, dream it up, draw it up, and I suppose if you have a CNC machine, cut it up and make some parts, man. Thanks for hanging out with me, you guys. We'll see you guys in the next one. Bye-bye.